Welcome to my presentation. This is lecture 012, area moment method. So this method for beam provide a semi-graphical technique for determining the slope of the elastic curve and its deflection due to bending. Objectives: computation of slope and deflection, analysis of indeterminate beams. Now for the discussion, the area moment method is one of the most effective methods for obtaining the bending displacement in beams. In this method, the area of bending moment diagrams is utilized for computing the slope and deflections at particular points along the axis of the beam. So, from the strength of material, a prismatic beam subjected to pure bending will bend into a circular arc for which the curvature expressed as K is equal to 1 over rho is equal to M over EI. So where K is the curvature, ang rho is the radius of curvature. M is equal to the internal moment in the beam at point where rho is to be determined. E is the modulus of elasticity. Yung I is the moment of inertia. Now we have this beam. Due to any loadings, it will deflect, and the deflection Y represented by the elastic curve. So let us take 2 points on the beam, say point A and B, and draw the tangent lines to point A and B. Then we have theta A and theta B represents the slope of the tangents at points A and B. So our target is to solve the change in slope between A and B. To do that, let us take 2 points with distance x from point B and with corresponding tangent and normal lines. So we have the central angle, we have point O, then the central angle, then the radius of curvature. So we have dx, then yung moment diagram. The shaded area is the area of moment diagram between A and B. So assuming EI is constant, then the area between A and B is equal to M times dx. Now for bending, K is equal to 1 over rho or is equal to M over EI. Now let us focus on the green lines. So we have arc length is equal to radius times the central angle. So we have dx is equal to ds, or yung arc length natin, no? So dx is equal to rho, or the radius of curvature, times the central angle, or d theta. D theta is equal to dx over rho. So d theta is equal to dx over rho, or 1 over rho times dx, or is equal to M over EI times dx. D theta is equal to 1 over EI times M times dx. So we have to integrate. So 1 over EI times the integral of m times dx. So yung limit, so from a to b. So m times dx represents the area of moment diagram between a and b. Or theta AB is equal to 1 over EI times the area of moment diagram between A and B. So this equation represents the theorem 1. Theorem 1 states that the rotation or change in slope between the tangents drawn to the elastic curve at any points A and B is equal to 1 over EI multiplied by the area of moment diagram between these points. So next, our target is to solve the TBA or the deviation of point B from the tangent drawn at A. So we have dt. Assuming EI is constant, then the area between A and B is equal to m times dx. Then yung centroid of moment diagram represents x bar. So focus tayo sa blue lines. Again, arc length is equal to radius times the central angle. So we have dt is equal to x times d theta. D theta is equal to dx over rho. dt is equal to x times dx over rho, or dt is equal to x times 1 over rho times dx. dt is equal to x times 1 over EI times dx. So we have to integrate. So 1 over EI times the integral of x times m times dx. So yung limit from b to a. Then yung m times dx, the area of moment diagram between a and b. So we have TBA is equal to 1 over EI times the area of moment diagram between A and B times the centroid or x bar from point B. So this equation represents Theorem 2. Theorem 2 states that the deviation of point B from the tangent drawn at A is equal to 1 over EI multiplied by the moment of area about B of that region in the moment diagram between points A and B. Now for the sign conventions for change of slope. If the rotation is counterclockwise, it is a positive rotation. If the rotation is clockwise, it is a negative rotation. Sign conventions for deviation. If the point is above the tangent line, it is positive deviation. If the point is below the tangent line, it is negative deviation. Now for the moment diagram by parts. The construction of moment diagram by parts depends on the two basic principles. Number 1, the resultant bending moment at any section caused by any load system is the algebraic sum of the bending moments at that section caused by each load acting separately. So we have M is equal to the summation of moment at left is equal to summation of moment at right. Number 2, the moment effect of any single specified loading is always some variation of the general equation. So we have spandrel. Mostly kasi sa moment diagram by parts are spandrel. So we have the general equation, y is equal to k times x raised to n. So the area of spandrel is equal to 1 over n plus 1 times b times h. Then yung centroid or yung x bar is equal to 1 over n plus 2 times b. Note that the n, the value of the degree of each equation. Then ito yung mga moment by parts, moment diagram by parts. So single load, so we have triangle. Yung n is equal to 1. Then for the moment, so rectangular yung shape. Then yung n is equal to 0. Then for uniform load, so we have n is equal to 2. Then for the triangular load, yung n is equal to 3. Example, from the figure shown, determine the reaction at B and the reactive couples acting on beams A and C. Use area moment method. So yung AI is constant. So based on the figure, so we have two cantilever beams. So solution, due to 150 kilonewtons load, magde-deflect yan by y1, and due to reaction at point B, babalik siya ng konti. So we have y2, then we have y, yung difference ng y1 at y2. Then we have segment beam AB. So we have y, then yung y is equal to y1 minus y2. Due to 150 kilonewtons per meter load, so we have y1, so this is degree 2, or yung n is equal to 2. Then we have moment, resultant moment, so negative 675 over EI. Then the centroid, yung TBC is equal to y1 is equal to 1 over EI times the area between BC times the centroid from point B. So yung y1 is equal to 1/3 times 675 over EI times 3 times the centroid from point B. So we have 2.25. Yung y1 in terms of EI, so is equal to 6,075 over 4 EI. Then due to reaction at B, so we have y2, then we have triangle, so we have moment or the resultant moment, so 3 times RB over EI. Then the centroid, yung TBC is equal to y2 is equal to 1 over EI times the area between B and C times the centroid or x bar from point B. So yung y2 is equal to 1 half times 3 times RB over EI times 3 times the centroid from point B. So we have 2. So yung Y2 in terms of RB over EI, so 9 times RB over EI. So consider beam AB. So we have Y. Then we have resultant moment, so negative 3 times RB over EI. Then the centroid, yung TBA is equal to Y is equal to 1 over EI times the area between A and B times the centroid from point B. So yung Y is equal to 1 half times 3 times reaction B over EI times 3 times the centroid. So we have 2 meters from point B. So Y is equal to 9 times RB over EI. So we have Y. So balik tayo sa formula. So Y is equal to Y1 minus Y2. So yung Y is equal to 9 times RB over EI is equal to Y1 6,075 over 4 EI minus sa Y2. So we have Y2 9 times RB over EI. So cancel out yung EI. So yung RB is equal to 84.375 kilonewtons. Now for the reactive couples, so we have moment at A. So considering beam AB or segment AB, so using the basic principle of equilibrium, so summation of moment at point A is equal to 0, considering counterclockwise positive. So M minus 84.375 times 3 is equal to 0. So yung MA is equal to 253.125 kilonewton meter. So this is counterclockwise. Now for the reactive couples, so MC, consider beam BC or segment BC. So summation of moment at point C is equal to 0, considering counterclockwise positive. So negative MC minus 84.375 times 3 plus 150 times 3 times 1.5 is equal to 0. So yung MC is equal to 421.875 kilonewton meter. So this is clockwise. Okay. Example number 2. From the figure shown of the clamped A36 steel beam, so we have E is equal to 200,000 megapascal. The spring has a stiffness of 2 newtons per mm. The beam is 5 mm wide and 10 mm high. Using area moment method, determine the deflection at the end B and find the force exerted by the spring. Solution. For moment of inertia, so we have I is equal to 1 over 12 times 5 times 10 raised to 3 is equal to 416.667 mm to the fourth. Now, due to 50 newtons load, magdi-deflect siya by Y1. due to reaction exerted by the spring, babalik siya ng konti. So we have y2. Then we have y, yung difference ng y1 at y2. So y is equal to y1 minus y2. Due to 50 newtons load, so we have y1, then the resultant moment sa point A, so we have negative 10 over EI. Then the centroid, so we have TBA is equal to y1 is equal to 1 over EI times the area of moment diagram between A and B times the centroid or x bar from point B. So y1 is equal to 1/2 times 10 over EI times 0.20 times the x bar. So we have 2 over 15. So y1 is equal to 2 over 15 EI. So Newton meter raised to 3. So y1 is equal to 2 times 1000 raised to 3 all over 15 times EI. So y1 is equal to 1.6 mm. Due to reaction exerted by the spring, so we have y2, then the resultant moment at point A is equal to 0.2 times RB over EI. Then the centroid, yung TBA is equal to y2 or is equal to 1 over EI times the area of moment diagram between A and B times the centroid from point B. So yung y2 is equal to 1/2 times 0.2 times RB over EI times 0.2 times the centroid, so 2 over 15. So y2 is equal to RB over 375 EI. So yung y2 in terms of RB, so RB times 1000 raised to 3 all over 375 times EI. So yung y2 in terms of RB is equal to 0.032 times the RB. So expressed in mm. Now for the RB, so RB is equal to K times Y. So Y is equal to y1 minus y2. So yung original formula natin. So yung y is equal to RB over 2. So is equal to y1. So yung y1 natin is equal to 1.6 minus y2. So 0.032 RB. So yung RB is equal to 3 newtons. Then yung y is equal to 1.5 mm. Okay? Example number 3. For the beam in the figure shown, compute the slope and deflection at point B. So, yung A natin is equal to 29 times 10 to the power of 6 psi. And I is equal to 2,250 inch to the fourth. Solution for deflection at point B. Reaction at A is 20 kips and reaction at C is equal to 25 kips. We have an elastic curve, then the deflection at point B or YB. Then we have tangent line and deviation of point C from the tangent drawn at point A or TCA. And we have also the deviation of point B from the tangent drawn at point A. And we have angle theta or slope at point A. For moment by parts, we take resultant moment at point B for 20 kips reaction. So naka-triangle, we have 400 over EI. For 25 kips reaction, naka-triangle pa rin. So we have 250 over EI. For triangular load, sa left side, we have negative 200 over EI. Since naka first degree yung load, our moment is third degree curve. For triangular load sa right side, so we have negative 50 over EI. So naka third degree curve siya. For centroids, for 400 over EI. So 20 over 3 feet from point B. For 250 over EI. So 10 over 3 from point B. For negative 200 over EI. So 4 feet from point B. For negative 50 over EI, so naka 2 feet from point B. For deviation of point C from the tangent drawn at point A or TCA is equal to 1 over EI times the area of moment diagram between A and C times the X bar C or yung TCA. So TCA is equal to 1/2 times 250 over EI times 10 times the X bar, so 20 over 3 plus 1/2 times 400 over EI times 20 times the centroid, so 20 over 3 plus 10 minus 1/4 times 50 over EI times 10 times the centroid, so times 8 negative minus 1/4 times 200 over EI times 20 times 14. Yung TCA natin is equal to 60,000 over EI. For deviation of point B from the tangent drawn at point A or TBA is equal to 1 over EI times the area of moment diagram between A and B times the X bar B. Or yung TBA is equal to 1/2 times 400 over EI times 20 times 20 over 3 minus 1/4 times 200 over EI times 20 times 4. Yung TBA natin is equal to 68,000 over 3 EI. So by similar triangle, so ratio and proportion, so YB plus TBA over 20 feet is equal to TCA over 30 feet. So substitute yung value ng TBA at yung TCA. So YB is equal to 52,000 over 3 EI. So keeps fit to the cube or to the 3. So YB is equal to 52,000 times 1,000 times 12 raised to 3. So over 3 EI. So YB is equal to 0.459 inch. So downward. Okay. So for slope at point B, so we have an elastic curve. So the tangent drawn at A, so we have angle theta. So we need to draw tangent line at point B with corresponding horizontal line. So this is angle theta, and this is angle theta also. And we have theta AB, or change in slope between the tangents drawn to the elastic curve at points A and B. And of course, our required, the theta B, or slope at point B. So theta B is equal to theta A minus theta AB. For theta A, so since our slope is very small value, so tangent theta A is equal to theta A. So theta A is equal to TCA over 30. So theta A is equal to 60,000 over 30 EI, or is equal to 2,000 over EI. Now for the theta AB is equal to 1 over EI multiplied by the area of moment diagram between points A and B. So theta AB is equal to 1/2 times 400 over EI times 20 minus 1/4 times 200 over EI times 20. So yung theta AB is equal to 3,000 over EI. So yung theta B natin is equal to theta A minus theta AB. So theta A natin is equal to 2,000 over EI. So minus sa theta AB. So 3,000 over EI. So theta B is equal to negative 1,000 over EI. So keeps feet squared. So theta B natin is equal to 1,000 times 1,000 times 12 raised to 2 over EI. So theta B natin is equal to 0.00221. So expressed in radian. So since negative, so naka-clockwise siya, no? Okay? Example number 4. From the beam shown in the figure, using area moment method, determine the deflection at 60 kips load. Yung A natin is equal to 29 times 10 to the power of 6 psi. Solution using equilibrium equation. Reaction at A is equal to 10 kips. Then reaction at point C is equal to 90 kips. we have an elastic curve, then the tangent line drawn at A, we have slope at point A or theta A, then deflection at point B. We have deviation of point B from the tangent drawn at A or TBA, and deviation of point C from the tangent drawn at A or TCA. For moment by parts, we take resultant moment at point C. So for 10 Gibbs reaction, so naka-triangle, so we have 200 over EI. Since magkaiba yung moment of inertia ng segment AB at segment BC, hatiin natin ang triangle. So sa point B, we have 100 over EI. Then the trapezoidal shape, we can divide it by into a triangle and rectangular shape. For 60 Gibbs load, so naka-triangle, we have negative 600 over EI. Then for 40 Gibbs load, we have negative 400 over EI. And for centroids at segment BC, so for triangle, so we have 10 over 3 from point C. For triangle, so we have 5 feet from point C. So at segment AB, so we have 10 over 3 from point B. At segment BC, so for negative 600 over EI, so we have 10 over 3 from point C. At segment CD, for negative 400 over EI, so we have 10 over 3 from point C. For deviation of point C from the tangent drawn at A or TCA is equal to 1 over EI multiplied by the area of moment diagram between A and C times the X bar C, or yung TCA is equal to 1/2 times 100 over E. So yung I natin is equal to 1,800 times 10 times the centroid, so 10 over 3 plus 10 plus 1/2 times 100 over E, so yung I natin is equal to 3,600 times 10 times the centroid, so 10 over 3 plus 100 over E times the I, so 3,600 times 10 times 5 minus 1/2 times 600 over E times I, so 3,600 times 10 times the centroid, 10 over 3, so yung TCA natin is equal to 25 over 9E. Okay? For deviation of point P from the tangent drawn at A or TBA is equal to 1 over EI multiplied by the area of moment diagram between A and B times the X bar B, or yung TBA natin is equal to 1/2 times 100 over E, so yung I natin is equal to 1,800 times 10 times the centroid, so 10 over 3, so yung TBA natin is equal to 25 over 27E. Okay? So by similar triangle, so ratio and proportion, so YB plus TBA over 10 feet is equal to TCA over 20 feet. So insert lang natin yung value ng TBA, then yung TCA. So YB is equal to 25 over 54E. So express in keeps times feet to raise to 3 over inch to the fourth. So yung YB is equal to 25 times 1,000 times 12 raised to 3 over 54 times E. So 29 times 10 to the power of 6. Or yung YB is equal to 0.0276 inch. So downward. And then this is the final answer na. Example number 5. Determine the reactions at the supports. EI is constant. Solution. We have reaction at point B or RB, reaction at point C or RC, and moment at point C. Now we can introduce the elastic curve, then the tangent line drawn at point C. Now for the moment by parts, we can take resultant moment at point B. For RC, we have 3RC over EI. For MC, we have negative MC over EI. For 6 kN per meter uniform load, at segment BC, we have negative 27 over EI. Then, naka second degree curve. For 6 kN per meter triangular load, at segment AB, we have negative 9 over EI. Then, naka third degree curve. For centroids, for 3RC over EI, we have 1 meter from point A, for point B. For negative MC over EI, we have 1.5 meters from point B. Then for negative 27 over EI, we have 3 over 4 meter from point B. Then for negative 9 over EI, we have 3 over 5 meter from point B. Now, using whole system of beam, summation of moment at point B is equal to 0. Considering counterclockwise, positive. So, RC times 3 minus MC minus 6 times 3 times 1.5 plus 1 half times 6 times 3 times 1 is equal to 0. So, 3RC minus MC is equal to 18. So, this is equation number 1. So, the deviation of point B from the tangent drawn at point C or TBC is equal to 0. So, TBC is equal to 1 over EI times the area of moment diagram between points B and C times the X bar B. So, 1 half times 3RC over EI times 3 times 1 minus MC over EI times 3 times 1.5 minus 1/3 times 27 over EI times 3 times 3/4 is equal to 0. So, cancel out yung EI. So, we have 9 RC over 2 minus 9 MC over 2 is equal to 81 over 4. So, this is equation number 2. Our summary for equations using calculator. So, RC is equal to 6.75 kilonewtons. Then for MC, we have 2.25 kilonewton meter. Then for reaction at B, so balik lang tayo sa original beam. So summation of forces along Y is equal to 0. So RB plus 6.75 minus 6 times 3 minus 1/2 times 6 times 3 is equal to 0. So, yung RB is equal to 20.25 kilonewtons. Okay? Example number 6. Using the area moment method, determine the deflection and slope at point B. So, yung A natin is equal to 29 times 10 to the power of 6 psi. Solution. For reactions, we have 72 kips. We have an elastic curve. Then we have YB. We have tangent line at point A. Then the deviation of point P from the tangent line drawn at point A, or TBA. Then we have deviation of point C from the tangent drawn at point A, or TCA. We have an angle theta at point A. For moment by parts, we can take the resultant moment at point B. For reaction at C, so we have 1728 over EI. For uniform load, so we have negative 1152 over EI. So, sa segment BC, so naka second degree curve. For reaction at A, we have 864 over EI. For uniform load at segment AB, we have negative 288 over EI. Naka second degree curve. For centroids, so for 1728 over EI, so we have 8 feet from point B. For 1152 over EI, so we have 6 feet from point B. For negative 288 over EI, so we have 3 feet from point B. For 864 over EI, we have 4 feet from point B. For TCA is equal to 1 over EI multiplied by the area of moment diagram between A and C times the x bar C, or TCA is equal to 1/2 times 1728 over EI, or yung value ng I is equal to 2,500 times 24 times 16 plus 1/2 times 864 over EI. So value ng I is equal to 4,000 times 12 times 28 minus, so 1/3 times 1,152 over EI. So value ng I is equal to 2,500 times 24 times 18 minus 1/3 times 288 over EI. So value ng I is equal to 4,000 times 12 times 27. So TCA is equal to 94.8672 over E. Okay? For TBA is equal to 1 over EI multiplied by the area of moment diagram between A and B times the x bar B, or TBA is equal to 1/2 times 864 over EI. So yung value ng I is equal to 4,000 times 12 times 4 minus 1/3 times 288 over EI. Value ng I is equal to 4,000 times 12 times 3. So TBA is equal to 4.32 over E. Okay? So by similar triangle, so YB plus TBA over 12 feet is equal to TCA over 36 feet. So substitute the value of TBA and TCA. So yung YB is equal to 27.3024 over E expressed in kips times feet cube over inch to the fourth, or yung YB is equal to 27.3024 times 1,000 times 12 raised to 3 over E. So we have 29 times 10 to the power 6, or yung YB is equal to 1.63 inches. So downward. Okay? For slope at point B, we have an elastic curve, then the tangent line at point A, we have angle theta A, then we have tangent line at point B with horizontal line. So this is theta A. So we have theta AB, or change in slope between the tangents drawn to the elastic curve at points A and B. Then we have theta B, or slope at point B. So theta B is equal to theta A minus theta AB. Now for the theta A, since our slope is very small value, our tangent theta A is equal to theta A, or is equal to TCA over 36. Theta A is equal to 94.8672 over 36E, or is equal to 2.6352 over E. Now, for theta AB is equal to 1 over EI multiplied by the area of moment diagram between points A and B. So theta AB is equal to 1/2 times 864 over EI. So yung value ng I is equal to 4,000 times 12 minus 1/3 times 288 over E times 4,000 times 12. So ang theta AB natin is equal to 1.008 over E. Okay? So theta B is equal to theta A minus theta AB. So theta B natin is equal to, so value ng theta A is equal to 2.6352 over E minus theta AB. So value ng theta AB is equal to 1.008 over E. So ang theta B natin is equal to 1.6272 over E expressed in keeps feet squared over inch to the fourth. So ang theta B is equal to 1.6272 times 1,000 times 12 squared over 29 times 10 to the power of 6. Or yung theta B is equal to 0.00808, so expressed in radian. So since positive, naka counterclockwise. Okay? Example number 7. From the figure shown, find the reactions at the supports. EI is constant. Solution. We have reaction at A or RA, reaction sa C or RC. We have MA, then MC. We have an elastic curve, then the tangent lines at A and C. Since the tangent line drawn at A and C are horizontal, the angle between the tangents drawn to the elastic curve at points A and C is equal to 0. So yung AC is equal to 1 over EI multiplied by the area of moment diagram between A and C is equal to 0. Then the TCA is equal to 1 over EI times the area of moment diagram between A and C times the X bar C is equal to 0. So this is TCA. For moment by parts, so we take resultant moment at point C. So for RA, we have 6 RA over EI. For MA, we have negative MA over EI. For trapezoidal load, hahatiin natin yan. We have triangle and rectangle. For rectangular load, we have negative 96 over EI. So, naka second degree curve. For triangular load, we have negative 8 over EI. So, naka third degree curve. For centroids, for 6 RA over EI, we have 2 meters from point C. For negative MA over EI, we have 3 meters from point C. For negative 96 over EI, we have 1 meter from point C. For negative 8 over EI, we have 4 over 5 meters from point C. Okay? So, theta AC is equal to 1 over EI times the area of moment diagram between A and C is equal to 0. So, we have 1 half times 6 RA over EI times 6 minus MA over EI times 6 minus 1/3 times 96 over EI times 4 minus 1/4 times 8 over EI times 4 is equal to 0. So, yung E cancelled out. So, we have 18 times RA minus 6 MA is equal to 136. So, this is equation number 1. So, we have TCA is equal to 1 over EI times the area of moment diagram between A and C times the X bar C is equal to 0. So, 1 half times 6 RA over EI times 6 times 2 minus MA over EI times 6 times 3 minus 1/3 times 96 over EI times 4 times 1 minus 1/4 times 8 over EI times 4 times 4 over 5 is equal to 0. So, yung yung EI cancelled out. So, we have 36 RA minus 18 MA is equal to 134.4. So, this is equation number 2. Now, for this summary of equations, so equation 1 and equation 2, using calculator, so yung RA is equal to 15.20 kilonewtons. Yung MA is equal to 22.933 kilonewton meter. Okay? For reaction at C, so balik tayo sa original beam. Summation of forces along Y is equal to 0. So, RC plus 15.2 minus 12 times 4 minus 1 half times 3 times 4 is equal to 0. So, RC is equal to 38.8 kilonewtons. Okay? For moment at point C, so using summation of moment at C is equal to 0, considering counterclockwise positive. So, negative MC plus 22.933 minus 15.2 times 6 plus 12 times 4 times 2 plus 1 half times 3 times 4 times 4 over 3 is equal to 0. So, yung MC is equal to 35.733 kilonewton meter. Okay? For our references,